This is the third part of day 1 two-phase flow back and Brill. Okay, and continue with this phase flow pattern. Okay, the flow pattern. So back and Brill define this line has a certain equation. This line has a certain equation, and this line also, and this line also. This line is called L1, and this one is called L2. This one is called L3. This one is called L4. So everything under L1 and L2 is segregated. Everything above L3, below L4, and also below L1 is called intermittent flow. And then everything above L1 and above L4 is called distributed, and everything between L2 and L3 is called transition flow. So what is L1 and L2 and L3? So this is the equation for L1 and L2 and L3 and L4. Means this one actually for L1, okay, is equal to L1. The equation is NFR equal to 316 lambda L to the power spawn 0302. So L2, the equation should be Froth number equal to 0.00925 lambda L to the power of minus 2.468. So that supposed to be the notation. But to make simplify, back sample using L1, L2, L3, and L4 because it's the notation for that lines. So first we have to construct this for line. So what we should do, actually, let's go back to back and Brill here. Okay, this is what it mentioned here. So L1, L2, L3, L4, which is should be an FR equal to 316, etc. L2 and FR equal to something, L3 and FR equal to 0.1, etc. And L4 is an FR equal to 0.05 and etc. So the segregated flow regime is simple actually. Let's go back to here. Okay, lambda L has to be below 0.0 and an FR lower than L1. So 0.01. Okay, so it's L1 below L1. Okay, lambda L has to be below L1. So this area here below L1, and NFR below L1. See, so lambda L below 0.01 and FR below L1. So this area NFR. So this area here, and the second one here, the second one. If lambda L higher than 0.01, and FR has to be lower than L1. So it has to be 0.01 larger, so lower than this one. So this area here, the second constraint is this area, not this area, so up to until the bottom, until everything else. So the constraint in this area around here, two constraints for segregated. And then for transition, so if it's lambda L larger than 0.01, so lambda L has to be larger than 0.01, larger than 0.01, and NFR between L3 and L2. So NFR should be larger than L2, lower than L3. NFR larger than L2 and lower than L3. So this is in this area. And then the third one is intermittent. So the first part, if lambda L between 0.01 and 0.4, lambda L between 0.01 and 0.4 here, okay, so between here and here, okay, this is 0.4 here. So L and FR between L3 and L1. This is L1, this is L3. So we're talking about this area, okay. So bit larger than 0.01 and lower than 0.4, and this is the area lower than L1 NFR, higher than L3 NFR. And the fourth one and the last one, not the last one, the intermittent one, the second of the intermittent one. If lambda L is larger, lambda L is larger than 0.4, this should be larger than 0.4, and NFR is lower than L1. So in this area, so if it's larger than 0.4, so it will be below L4, and larger than L3 should be that way. Okay. This one, the first one here is this area. The second one in this area. So this is L4 and FL larger than L. Oh, sorry, this one. Lambda L larger than 0.4 is between L3 and L4. Okay. If it's lower than 0.4 between L1 and L3, larger than 0.4 between point and L3 and L4. Okay. And then the fourth one is distributed. It's outside here. So if it's lower than lambda L lower than 0.4, lambda L open than 0.4 should be higher than L1. If the lambda L higher than 0.4 should be higher than L4, the NFR here. Okay, so that's basically. So I will ask you to construct this graph. I will show you the example.